Hello and good evening. The following video tutorial will be a CCNA level video tutorial that's going to deal with EtherChannel and spanning tree, and specifically the cost of an EtherChannel interface based on the number of ports that are inside that EtherChannel and how it'll impact the cost of the spanning tree port between two switches. So let's go ahead and get started here first on switch number 1. And so the first thing we want to do is we go from user exec into privilege exec and then into global config mode. And so this is our switch 1 switch. And then we're also going to go ahead and set the spanning tree cost. And so if you take a look here, we'll do spanning tree VLAN 1 and we'll set the priority here to 4096. And that's going to force switch 1 to become the root switch for the spanning tree domain. So if I do a show spanning tree, do show spanning tree, you can see here that for VLAN 1, this bridge is the root. All right. Now, for fast Ethernet interfaces, the cost of the port for a 100 meg port for a fast Ethernet interface is simply, and we're going to go ahead, I'll make a note here, so for fast Ethernet interfaces, if you have a single fast Ethernet interface, semi-straight line, your cost will be 19, right? As you can see right over here, the cost is 19. So what happens when we add in 2 or more interfaces? And we're also going to take a look at the spanning tree cost method long, which is something that you typically see with either MST, multiple spanning tree, or RSTP, rapid spanning tree protocol. But you can also use it with, well, I should say you can use it with PVST, which is Cisco's implementation of spanning tree. And really, with Cisco's implementation, it's kind of a an RSTP compatibility type mode, because 802.1d, which is what PVST was based on, has been deprecated now for quite some time. So let's go ahead and take a look here at what happens when you create, and I'll go ahead and draw a line down here because we're going to also take a look at the long costs, right, and what those look like. So the default long cost is 200,000 for a single port. Try to keep these lines as straight as I can here. So we'll go forward and do the regular 16-bit costs, and then we'll use the 32-bit costs for the long mode, and we'll get those filled in here shortly. All right, so without further ado, let's go ahead and we're going to go into interface range FA 1013 to 14. We'll shut those interfaces down initially, and now we're going to create our port channel. Whoops. So channel group 1 mode, and we'll use LACP. So we'll set that to active, and then we'll say no shut. So now switch 2 is the other end of this link. As you can see, we've got some messages here. So let's go ahead and go from user exec into privilege exec and then into global config. We'll set the host name of the switch to switch 2, and then we'll do the same thing, interface range, and this is FA 6013 to 14. And we're going to shut these down, and then we're going to say channel group, channel group 1 mode active. And then we'll say no shut. So on switch 2, if I do a do show spanning tree, you can see here that our port channel interface is our root port. It's actually transitioning. It's in the listening stage right now, and we should see in the next few seconds here that it's going to transition to the learning state, which it has. So it went from listening to learning. And remember, it says spanning tree is enabled by the protocol IEEE. If I do a do show spanning tree summary, you'll see that the mode, the switch is in PVST mode. So we're using the 802.1d protocol, right? But Cisco's implementation of that, or the mode that we're doing, is per VLAN spanning tree. Because remember, by default, or I should say, the original standard for 802.1d was not multiple instances of the spanning tree protocol running, one per VLAN. It was a single instantiation of the spanning tree protocol. And so with per VLAN spanning tree, we have an instance of spanning tree running for every VLAN. And that's what that per VLAN means. So you can see that we're in PVST mode here. So we're going to be going through the listening, the learning, and ultimately, and we should be there, the forwarding state, right? So now this EtherChannel port channel 1 is forwarding, and when we added in a second 100 meg link, the port cost dropped to 12, right? So let's go ahead and let's add in a third link and see what happens here. So I'm going to go ahead and say exit, and we'll say interface FA6015, and we're going to go ahead and do channel group, channel group 1 mode active, and then we'll come to the other side, and we're also going to do the same thing here. I actually want to go into interface FA1015 1/0/15, and we're going to say channel group 1 mode active. And we should get a message here from the switch telling us that the link is up. So if I do a do show EtherChannel, and we actually want to see summary, you can see now that I've got 3 ports, but the third one we just added is waiting to be aggregated. So it won't be until we see the P there where it's been fully bundled in the port channel and is being used. If I do a do show span for our spanning tree status, you can see that this is my designated port because, again, this is the root bridge, and you'll notice it still showed 12. Then we saw this message here stating that the interface, the line protocol, is now up. So if I do a do show EtherChannel summary, that link is now bundled in the port channel. So now if we look at the spanning tree, as you would expect, once that port is in the port channel and the line protocol is brought up, we now have 3 links, and so this cost has now been dropped to 9. Right? So with 1 link, it's 19. With 2 fast Ethernet links, it's 12. With 3 fast Ethernet links, it is 9. And so let's add a 4th. So we'll do int FA1033, and unfortunately, that's just the way the switches are connected. Group 1 mode active, and then I'm going to come over to switch 2. We'll do the same thing. Interface FA6033. And we'll say channel group 1 mode active, and we're going to see the same thing here. So the line protocol is down, so if I do a do show span, do show span, we would expect to see that the cost is still 9. Even though we've added a 4th link, that link is not fully negotiated and is certainly not in the port bundle. So if I do a do show EtherChannel summary, you can see we're still waiting for this port to be aggregated. And so this is exactly what happened last time. You can see that the port is down, and on switch 1 is going to report the same thing. If I do a do show EtherChannel summary, so now it's an H, hot standby, and there you go. The line protocol on the interface changed to up. It is in the bundle. So do show spanning tree, And we see now that with 4 links, the cost has been dropped to 8. All right, so let's go ahead and add in a 5th link. So we're going to go next to interface FA1035, and we're going to say, actually, let me cut and paste this. Could have typed it by now, so let me just roll back and we'll get it typed in here. So we'll say channel group 1 mode active, and we'll do the same thing for the interface, the corresponding interface on switch 2. So interface FA6035 and channel group 1 mode active. Whoops. All right, so we should see, as we did last time, the line protocol on that interface will go down. Do show EtherChannel summary is going to show us that, again, that's in the waiting state right now. If I do a do show span, even though we have a 5th port that's just been added, the cost is still at 8. And then over here, do show EtherChannel summary, we should see that it's in the waiting state. Oh, it's transitioned to the hot standby, and now it should quickly transition into the bundled state with a P there, and we're going to get a message here to the terminal shortly telling us that the line protocol on FA1035 is up. So now if I do a do show EtherChannel summary, we see that it's fully bundled here. If I do a do show span, let's see if the cost has dropped again, because at this point we now have 500 megabits a second of throughput that, or I should say, of bandwidth that is available. Okay, so the cost has now dropped to 7, right? So the cost with 5 links drops it to 7. So let's add in another one, int FA1037, and we're going to say channel group 1 mode active. And we'll come over to switch 2 and we'll do the same thing. Interface FA6037, channel group 1 mode active. And you'll see those interfaces go down. So if I come back to switch 1 and I do actually let's take a look on switch 2 here. Do show span. You can see that the status, or I'm sorry, the states of the port, right? The port state, forwarding, blocking, and the role. And this is very interesting. So the role, you'll notice we have designated, alternate, and root. However, we're running Cisco's version of, or Cisco's sort of adaptation of the original spanning tree protocol 802.1d. So we're running per VLAN spanning tree. And what's interesting is that these port roles, specifically the alternate port role, is a port role that is not available under per VLAN spanning tree. So typically you see this with rapid spanning tree protocol, or RSTP, and that's where you'll see these port roles. And the reason that you see this here is, again, 802.1d has been deprecated for quite some time, and it really doesn't make that big of a difference to show these roles here, because the PVST, it's really almost running in sort of an RSTP compatibility mode, right? And so that is why you see the roles of the ports displayed here, even though we are not running Rapid Spanning Tree Protocol, or RSTP. And so that's why the RSTP port roles will show up here while running per VLAN spanning tree. Okay, so our port is up now. So if I do a do show span, let's see if the cost dropped. It did. It's now dropped to 6. So let's add in our, whoops, let's add in our 6039 and channel group 1 mode active, and int FA1039 channel group mode, channel group 1 mode active. Okay, and so that line is going to go down. And then when we see it come back up, I'm going to go ahead and I'm going to fill the costs in. So with 7 ports, we're going to see a cost of 5. Now, intuitively, you would think that the 8th port that gets added in, right? Remember, we're talking about fast Ethernet interfaces, so 100 megabits a second. So when we're here, we're going to have 800 megabits per second of bandwidth that's available. And earlier I had said throughput, I misspoke, and I corrected it right away. So 800 megabits per second of available bandwidth. However, the throughput is determined by a multitude of other factors. So we're going to have 800 megabits per second of bandwidth available. And another key thing to remember with EtherChannel that a lot of students don't understand is this 800 megabits doesn't mean we can have a single conversation going back and forth that's transferring 800 megabits a second. What it means specifically in the context of we're using 100 meg ports, these are fast Ethernet ports, so you could have 8 100 megabit per second conversations, right, that are mutually exclusive, but you could not have a single 800 megabit per second conversation taking place. So in layman's terms, what's happening here is with the EtherChannel, your conversation between the source host and the destination host will pick one of the 8 links that's available to go over. And then there are different load balancing. You can do source and destination port, source and destination IP to ensure that the traffic is evenly spread across these 8 ports. However, you are still going to be limited by the 100 megabits per second. So again, don't make the mistake of thinking, oh, I could have a single conversation between a source and destination host that's going to yield 800 megabits per second of available bandwidth. It is not. You are still limited to the lowest common denominator in that port channel or that EtherChannel bundle, and in our case it's 100 megabits per second. Okay, so again, intuitively you would think, you've seen here, right, it goes 9, 8, 7, 6, 5. You would think that this is going to be 4, right? However, a gigabit gigabit Ethernet interface, so gig 01, gigabit will have a cost of 4. So if we're saying that this is going to be 8 links, right, and it's only going to be 800 megabits per second of available bandwidth, then we don't want it to be 4, because we want the gig link to have a better cost than a port channel that's only 800 megabits per second of available bandwidth. So this is actually going to turn out to be 5, and we'll show that right now. So we've got our 7th link in here. So if I do a do show span, there are our costs, and you can see that it's 5. So we'll add the final and 8th link in here, 1041, and we'll say channel group 1 mode active, and we'll come over to switch 2. If I do a do show span, confirm that we see 5, we still do. So I'll do interface FA6041 and channel group, channel group 1 mode active. All right, and then these links are going to go down, but then they're going to come back up, at which point we're going to confirm and see that with the maximum of 8 links, and we have that number of links in our port channel, that the cost will still be 5, right? Because again, you do not want it to be greater than, or you do not want it to have a better cost than a gigabit interface, which can support a single conversation, and again, theoretically, up to 1,000 megabits a second or a gigabit a second. Obviously, there's going to be overhead involved, so you're never really going to achieve the maximum. You'll never get 1,000 megabits a second on a single gig link because of the overhead with TCP/IP. And so you're going to want that cost on the gig link to be lower. All right, so our 8th link has been added in. So now if I do a do show span, we can confirm that sure enough the cost is 8. Do show EtherChannel summary, and you can see that we have all 8 ports added in, right? So with 8 ports, the cost is 5. The spanning tree port cost will be 5. And that's the same as if we had 7 links. So now what we're going to do is we're going to back these ports out one by one, and this is a little quicker to do. But the first thing that we want to do is right now we're using a 16-bit integer to represent the cost. So the maximum value of the cost in the short form, which with the 16 bits, and we're kind of running out of space here, so we'll say with 16 bits, 16 bits, our cost will be between 1 and 65,535, right? With the long, your cost can be anywhere between 1 and 200 million. And here, with a long cost, this is also a 32-bit integer, right? But obviously, if you looked up 2 to the 32, it doesn't max out at 200 million. 2 to the 28 is pretty close, but 2 to the 32 is a little higher. So, but it stops at 200 million, right? All right, so here's how we're going to determine what those costs would look like in an Ether channel with fast Ethernet interfaces. So the first thing we need to do is we need to tell Spanning Tree that we want to change the way that it's calculating the cost. So I'm going to say Spanning Tree cost, Spanning Tree, let me make sure I get this right. I'm drawing a blank here. Is it path cost? Yeah, path cost method. And so you can see there's 2 methods you can choose from, long and short. Long is going to use the 32-bit base values, and short is only going to use the 16-bit. And short is what we're using now, and that's the default. So we're going to say long. Now, something interesting is going to happen. Do show Spanning Tree. And as you can see, our costs have changed. However, is this something that is just local to the switch? It certainly is. And as you can see here, the costs are different on this end. And so this is definitely a setting that you want to make sure I get that right. This is definitely a setting that you want to make sure. Tree cost. Oh, I'm in the interface. Hold on. Let me back out one level here. So Spanning Tree port. Let's make sure we get this right here. Port cost. Port cost and or path cost. I apologize. Path cost. And the choices will be from the method of short or long. So we're going to say long. So now when I do a do show Spanning Tree, the costs match up. And again, you want to make sure that these costs match up in your Spanning Tree domain. So with 8 links, our cost is 25,000. And so it'll be very easy here to back out and walk ourselves back to 2 ports. So if I simply do default interface FA6041, and then I'll step over here and do default interface FA1041. So those have been removed now. So if you do a do show EtherChannel summary, you'll see that we're back now to 7 links, and that 1 link has been removed, 41. So if I do a do show Spanning Tree, and what that command did, and let me actually take a step back, that command, that default interface command, simply just sets that interface back to its default configuration. And so now the cost is $28,570. So the cost is $28,570 when you have 7 links in the EtherChannel bundle. All right, and so now let's go ahead and do default interface FA1039. And we'll come over to switch 2 and remove that link. Default interface FA6039. Do show span. And we should see that we've got a different value in here now. So with only 6 links in the bundle with fast Ethernet interfaces, our spanning tree port cost is $33,330. So let's come back over and we're going to say default interface 6030. Which one did we just pull out? 3937. Oops. Forget the FA there. All right, we'll pull 37 out over here. So default interface FA1037. And if I do a do show span, you'll notice that the cost is now $40,000. And something else that you'll notice, and one of the benefits of EtherChannel is that the port is in the forwarding state and it stays in the forwarding state the entire time. So even as I'm dropping out links from the bundle, it still stays in the forwarding state. And so that's the redundancy that an EtherChannel provides you, or a port channel provides you. All right, so let's go ahead and drop out the next interface. So default interface FA10, and we did 37, so 35. And we'll come over here and do the same thing. Default interface FA6035. So if I do a do show span, we'll see that the cost is now $50,000, right? And then we'll take it down to 3 links here. Default interface FA6033. And then default interface 1033. Oops. And did I do that? Did I typo that? All right, I did not typo that. All right, so over here, if we do show span, you can see we're still in the forwarding state, and the cost is now $66,660. So let's drop out one last interface here and take it down to 2. And so I'm going to say interface FA, oops, I'm sorry, default interface FA6015. And then default interface FA1015. So do show span, and our cost is simply half of what it would be with a single port, 100,000. Okay, so again, to recap, when you're creating ether channels, you're adding in additional links, and on the Catalyst platform we go up to 8, right? So these 8 additional links, obviously when you're adding those additional links, you're adding the capacity for additional bandwidth to be available, and therefore you're going to see, and you would want to have the cost of the ether channel ports to drop in tandem or at the same, or as you're adding in links, right? Because as you're adding in links, you're adding in available bandwidth. So then you would want these ports to be more attractive for Spanning Tree to choose to be either your root port or your designated port, right? But these are the ports that you would want Spanning Tree to choose because you've got redundancy built in and you have additional bandwidth, which will provide you with additional throughput. So the key thing to remember here is with fast Ethernet interfaces, when you get to 7 and 8, right, the cost will stay at 5 for both, right? And the reason for that is when you step up to a gigabit interface, that default cost is 4. And then over here, if you're doing the long method and you don't want to deal with the different costs that are 19, etc., you know, and so forth and so on, then you can do the long method, which can be from 1 to 200 million. And so a single fast Ethernet interface is 200,000. With 2, it's 100,000, and then 66, 660, 50,000, so forth and so on. And you'll notice that down here, the 7th and 8th links have different values, right? The values here are 28,570 and then 25,000. Okay, so this has been a tutorial on the spanning tree port cost and what happens when you're using EtherChannel to create the links. And keep your eyes peeled inside Packet Tracer. I had a conversation yesterday with one of the best instructors that I've worked with in a long time, and she was telling me that in Packet Tracer, what she was seeing is that the cost of the links, when you added in additional links into the EtherChannel and you went up to 8 links, that it was not following the 19, 12, 9, 8, 7, 6, 5, 5. That the values were different. And in fact, if I were to pull up, let's see which one we've got here. So if I were to pull up a blank spanning tree, let me cancel, I'm sorry, spanning tree, blank packet tracer activity. So let's pull up a blank packet tracer activity. And I'm going to make this a little bigger here. And let's test this and let's see what Packet Tracer shows us. And we're waiting for this guy to do his thing here. I had 2 VMs running earlier, and so I'm sure that this is a result of that. All right, so we'll come down here to the switches, and so I'll go ahead and pick 2960s. So I'll take 2 2960s out here. So there's one. And I'll put out here switch 2. So let's make these a little bigger. And then we'll go to the connections icon. And it should be MDIX. It should be able to figure it out. We'll find out right away. So we'll put in one straight through, and let me grab, I might as well grab a crossover. So let's see if it's got the MDIX capability here and see what's going to happen. So we'll pull up switch 1 real quick. We'll take a look at the CLI. And so we're going to go ahead and we'll set the configure the terminal. Yep. So we're going to configure the host name here. And we'll just say this is switch 1. All right. So good. It did not like that crossover cable. Good. Let's get rid of that crossover cable. Whoops. Let's just go with this. Whoops. The straight through cable here. So we'll say the straight through cable. FA02 to FA02, and then a straight through cable 03 to 03, and then 04 to 04, and 05 to 5, and 06 to 6, 7 to 7. Alright, so if I pull this up on switch 2, and let's put the host name on switch 2 of just SW2. If I do a, let's end out show, whoops, show interface status, and it doesn't like that, so show IP interface brief. Let's see what we've got here. So we've got 1, 2, 3, 4, 5, 6, 7 ports are up. Let me add that 8th link in. 08 over to 08. So there we go. And unfortunately, we're going to have a thick black line there on those interfaces. Enlarge switch 1. All right. So let's go ahead and let's initially just drop all 8 of these ports into a single ether channel. So if I were to say interface range FA 0/1 to 8, and I'll initially shut these guys down. We'll say channel group 1 mode active. So I've got a port channel now with 8 interfaces, so I'm going to go ahead and say no shut and bring those guys up. And then let's pull up switch 2. All right, bring it, there we go. Okay, switch 2's up here. So we're going to say interface range FA01 to 8, and I'll initially shut them down, and we'll do channel group 1 mode active, and then no shut. So those interfaces are going to come up. So if I do a do show span, you can see that the cost is 5. It's in the listening state, so it's making the transition from being down into the listening state and the learning state and then into the forwarding state. And as you can see here, we are running per VLAN spanning tree. Do they have the spanning tree summary command on here? They do. Fantastic. So the switch is in PVST mode, right? And I'll even flip the mode to rapid spanning tree. In fact, if I step over here while that's in listening and learning, if I were to say spanning tree mode and change it to rapid per VLAN spanning tree and then do this on both sides, and I'll copy that and we'll come over here to switch 2 and we'll run that same command. So I've just changed the mode on switch 1 and switch 2, and I've changed it to rapid per VLAN spanning tree. So if I do a do show span now, you can see we still have a long cost, but we're seeing different types of ports, whereas before we were seeing point-to-point, but now we're seeing point-to-point or peer STP, right? And the reason that we're seeing the peer STP here is that these are not set up for rapid per VLAN spanning tree right now, right? So all the ports in the port channel that we're using in port channel 1, those are set up. We've got the long cost set, and you'll notice it did not change our port cost. But now if I do a do show spanning tree summary, you can see the mode is rapid PVST mode, and spanning tree protocol is the rapid spanning tree protocol. So Cisco took initially, if we scroll back up a little bit here, so the protocol that's being used is this IEEE, which is the 802.1d, but Cisco took that and tweaked it, and they're using per VLAN spanning tree when you're using PVST. And then when we flip the mode to rapid spanning tree, to use the rapid spanning tree protocol 802.1w, we are now, and then Cisco took that and they said, okay, well, we're going to create rapid per VLAN spanning tree. So the protocol is the IEEE 802.1d or the IEEE 802.1w. However, the mode, which is the Cisco switches use of the standard spanning tree, right, took it, made the changes to it so that it's per VLAN. Okay? All right. So that's what happens when you change the mode. So let's come back over here and let's see if we can drop out. And I'm not sure if default interface FA 0/8. Oh, I'm sorry. Let's go do. Let's see if it likes the, or actually, I don't think it's going to like that. So if I start dropping links out, if I go into int FA 0/8 and shut it down and do a do show span, the cost is still 5. What if I go into int FA, and that was with 7 links. So 8 links was 5, 7 links was 5. If we take it to 6 links. Oops. Do a do show span. The cost is still 5. If I go into interface FA0/6 and shut it down, do show span, our cost is 5. And let me do show EtherChannel summary. So these are showing as down, not necessarily removed. Let me make sure that that is not what is causing it to stay at 5. So let's go into interface FA08 and say no channel, no channel group 1 mode active. And int FA0/7, no channel group 1 mode active. And now let's do a do show EtherChannel summary. So those ports are truly gone from the bundle. Let's make sure, and it still shows a cost of 5. So let's go into int FA0/6, no channel group 1 mode active. Do show EtherChannel summary. So port FA06 is gone. Do show spanning tree. And now the cost is 6. So as you can see, and let's get a page, pull up a new image here. So I'll say File, New, and don't save that guy. So with Packet Tracer, right, it's a little misleading. We're dealing with fast Ethernet interfaces, and with 8 interfaces, the cost was 5. With 7 interfaces, the cost was 5. With 6 interfaces, the cost was 5. And let me actually make sure I'm confirming that. So right now, 1, 2, 3, 4, I'm sorry, with 5, it's 6. And so here we had, oh, that's right, we did drop it out, and it was still 5. So let me add back in interface. Let's do a do show EtherChannel summary. So we've got 5 ports in here now. Let me add in int FA0/6, channel group 1 mode active. I just want to make sure channel group 1 mode, active. There we go. So if I do a do show EtherChannel summary, it's down, but it should be coming up here shortly. And then let's take a look with 6 links in there. If I do a do show spanning tree, so at 6 links, the cost was 5. So if I come back over here, the cost was 5 with 6 links. So with Packet Tracer, those are our costs. With the real iOS, on a real switch, when it's 8, it's 5. When it's 7, it's 5. But remember, when it's 6, the cost was 6. I apologize, 8, 7, 6. When it was 6, the cost was 7. All right. When there were 5, the cost was, I'm trying to keep this straight in my head here, was 8. When there were 4 links left, and I think I may have this backwards. So let me start from the top. I'm trying to work backwards. So with 1, it's 19. With 2, it's 12. With 3, it's 9. With 4, it's 8. With 5, it is 7. With 6, it's 6. And with 7, it's 5. And with 8, it's 5. Okay, there we go. I apologize there. I was trying to work backwards and getting confused with the numbers. So with 1 link, it's 19, 2, 12, 3, 9, 4, 8, 5, 7. 6 links cost of 6, 7 links cost of 5, and 8 links a cost of 5. But we saw in Packet Tracer, with 6 links, the cost is 5, which does not, it does not equal, it's not the same as what we see with the real iOS, and that's what we're confirming here right now. So let's do a do show EtherChannel. So that link is still showing as down. And let me go ahead and do no shut to make sure. Okay, there we go. All right. So there we go. Now it's in the bundle. Let's confirm, do show span, that the cost is in fact 5. So with 6 links in Packet Tracer, the cost is 5. So let's drop that link out now. So I'm going to say no channel group 1 mode active, right? And we'll shut the link down even. There we go. So now do show EtherChannel summary. We've got 5 links. So now when I do a do show span, the cost is still 6. So if I come over here with 5 links, the cost is now 6, whereas on the real iOS with 5 links, the cost was 7. So let's continue to drop links out here. So if I do interface FA 0/ or actually let's do a do show EtherChannel summary to make sure we're down to 1, 2, 3, 4, 5 links with a cost of 6. So if I go into int FA 0/5, do a no channel group 1 mode active, shut the interface down, do show span. So with do show EtherChannel summary with 4 links, the cost is 7. So with 4 links, our cost is 7. And again, that's off from the real iOS where the cost was 8. And then let's drop back in here and go into interface FA 0/4. We're going to take it down to 3 links now. No channel group 1 mode active. We'll shut the interface down. Do show EtherChannel summary. So we've only got 3 links. Do show span. And the cost is now 8 with 3 links in Packet Tracer. So with 3 links, the cost is 8. And again, it's just off of the cost with the iOS by 1. So we're going to change interfaces in FA 0/3. We're going to take it to 2 links. And we'll say no channel group, no channel group 1 mode active. And we'll shut it down as well. So now if I do a do show EtherChannel summary, we have 2 links left in our bundle. And do show spanning tree, the cost is 9. So with 2 ports, the cost is 9. However, on the iOS, the cost is actually 12. So as you can see, with Packet Tracer, the costs are different. They're the same here. Whoops. Let me clean that up. So from here, with 7 links, the costs are the same. However, once we transitioned to 6, 5, 4, 3, and 2 links, the costs are off. It's 9, 8, 7, 6, and 5. However, with the real iOS, it's 12, 9, 8, 7, and 6. So let's go back over here and let's drop the final interface out, FA 0/2, and we're going to say no channel group 1 mode active, and I'll even shut it down. So now if I do a do show EtherChannel summary, we've got that single link, do show spanning tree, and in fact, with 1 link, the cost is 12. And so let me take a look at that, because that's interesting. I would have thought that with 1 port, it would have gotten it. So let's go ahead and let me jump over to the other switch 1 real quick. And yeah, we're down to 1 link and it shows 12, and it should show 19. So let's go ahead and do interface range, make sure that it's not something 0/2 to 8. I'm going to shut those interfaces down. I'm going to say no channel group 1 mode active, and those are also shut down. So do show span shows a cost of 12, and if I do show EtherChannel summary, we've only got that 1 port in there. So on Packet Tracer, the cost with a single link even is showing 12 and not 19 as it should. And so just to make sure we've got everything shut down there, and let's take a look at switch 2 again, make sure nothing changed over here on switch 2. So do show EtherChannel summary, Still a single port, do show spanning tree. So the port channel with a single port has a cost of 12. And that should actually be the cost if there were 2 links in the EtherChannel bundle as we had previously seen. So again, just a quick note, right? Remember that Packet Tracer is not the full-blown Cisco IOS. And it's a fantastic tool to learn on, but again, some of these things will start to cause confusion when you're looking at the different costs, especially when you're creating Ether channels and your spanning tree costs are not matching up like you think they would. So again, the real iOS, it's 19, 12, 9, 8, 7, 6, 5, and 5. However, Packet Tracer is showing 12, 9, 8, 7, 6, 5, 5, 5. So definitely a discrepancy there, and something that you want to take into account when you're working with Packet Tracer. All right, so this wraps up my video on spanning tree protocol spanning tree protocol, and specifically with the spanning tree protocol, the port costs, and what happens to those port costs when you create an Ether channel and you start to add links into that Ether channel. All right, I hope you enjoyed this video, and best of luck.